scientists have a role to play in geoengineering. They need not to just discount it completely. They need to help and work perhaps with the geoengineering projects, use the models and use the data that they have and the understanding of the complexity of the systems that they have. It may be that they can see from their modelling, from their understanding of the impacts, that this is absolutely not the right thing to do. It could be a disastrous consequence. But I think the science must be done.
Hello and welcome to this episode of Beyond the Ice. My name is Em Newton and this is the podcast from British Antarctic Survey where our experts brief you on newsworthy polar and climate science. Today we're discussing geoengineering. Geoengineering is the deliberate, large-scale intervention in Earth's environment and natural systems. It's also known as climate engineering because the aim of these proposed projects is usually to offset the causes and impacts of climate change. From carbon dioxide removal projects to a recent US proposal to erect an underwater curtain around the West Antarctic ice sheet, there's a true range of geoengineering ideas emerging into the public discourse, and some of them are more sci-fi sounding than others. Geoengineering has become an increasingly emotive and divisive topic over the last few years. It touches on a range of political, economic and ethical sensitivities. And across the spectrum of opinion on geoengineering, people are motivated by a deep-rooted anxiety about the future of humans on this planet and our ability to take necessary action on climate change. To explore this debate with me, I'm joined by Professor Dame Jane Francis, who's the Director of British Antarctic Survey. Thanks for coming on the podcast, Jane.
A pleasure. Before
we jump into discussing geoengineering, can you help me set the scene? Earth's climate is changing now. What are we seeing happen in the natural environment?
So what we know now is that carbon dioxide levels are really shooting up very highly now, far higher than they've ever been. So from the research that we do here in Bass, we know that over the last 800,000 years, we can see a record of temperature and CO2 in the ice core record. So we go to Antarctica, we drill ice cores and we analyse both the water in the ice and the little gas bubbles which contain the CO2. And what we can see is that for the past 800,000 years, and we might even go back to 1.5 million now with the new ice cores, we have seen that carbon dioxide levels have never risen above about 300 parts per million. And although we have waxing and waning of ice sheets in the past, carbon dioxide levels have never risen much above 300. And if you go out and measure CO2 today, you will see that it's over 420-something parts per million. So if you see this on a graph, you'll see that it shot up in the late 1800s as a consequence of the Industrial Revolution and burning more coal and putting all that carbon that was buried as fossil plants in the ground, in coal, as burning that and putting it up into the atmosphere. And if you want to know what a world looks like at 400 parts per million, I can tell you as a geologist, we have to go back into the rock record. We can't even see it in the ice record. And then we look at different features of the geological record to tell us what the world was like at 400 parts per million. And just in case you ask me about that. So what we can tell from the geological record is that we're looking 2 to 3 million years ago, and we can see that global sea levels were higher. There was probably about 10 to 20 metres of global sea level rise. Mm-hmm. There was still ice on Antarctica, but much, much smaller ice caps. And generally, the Earth was probably about 2 or 3 degrees warmer. So looking back in the past is very valuable because it could tell us where we're going. We know in the past that carbon dioxide and temperature rose together. They moved together. So temperatures are also trying to increase rapidly as well. I think there's an imbalance at the moment with high CO2 and lowish temperatures. And the Earth's temperature is desperately trying to go up to match the CO2 levels. I'm not surprised that the climate is irrational, if you like, with lots of fires, with storms, with wind. I mean, it's really not in the kind of balanced state that it was.
And those are symptoms of change rather than a kind of stable, warmer state.
We have such high CO2 and that we're in a much warmer world, and the warmth then affects some of the very complex systems of the Earth's climate. Warming the ocean, that causes differential temperatures between ocean, land, atmosphere, and that causes storms, winds, affects so many things.
Yeah. Let's talk about geoengineering. Given the state of things, why do you think geoengineering has become such an emotive issue in the public sphere? Because I think on the surface of things, people who are behind geoengineering are clearly motivated to do something about the changing world that we're in.
I think that there are people who are really worried that government action is not fast enough to cope with our high levels of CO2. And we know what to do. We've got to take the CO2 out of the atmosphere. That is the solution. And there are ways to do it. And we need to find new ways to do it much faster. And we need to stop burning coal and gas, because that's putting more CO2 in the atmosphere. So we know what the solution is, but we don't know yet how to do it fast enough properly. And I think there's a lot of people that are genuinely worried and have the right motivation, but they just want it to go faster.
Yeah.
And I think I've talked to some of these people, and they genuinely do not think it's the whole solution, but they think this is an immediate action that we can take that may slow down climate warming. But of course, the problem is it's not attacking the cause of it at all.
Yeah, very often these, particularly the geoengineering projects that you see being talked about in the media at the moment, they are projects that are addressing an impact of climate change or a particular part of the natural system rather than the presence of additional carbon dioxide.
Exactly. So they're looking at an environment and they're trying to change the environment, make more clouds or stop warm water flowing around certain places, but there is still increasing CO2. So it's often described as trying to attack the symptoms rather than the cause of warming.
There is some disquiet in the science community, I would say, around geoengineering. And there's those who seem very opposed to it, perhaps on the general principle. Can you talk about where you think this perspective comes from among the science community?
I think some of the scientists really understand the specific environments, perhaps the ones that they're specialists in and they research in. One of the things that scientists do is they try and understand how the Earth systems work. And they do know that if you tinker with it, as we have with burning coal and gas, actually, it will fundamentally change some of the processes, which could lead to more severe damage, more severe impacts. Well, how can I find an analogue? If you're, I always use the cooking analogue.
Yeah.
So if you're cooking a cheese souffle, there's a nice recipe and you follow the recipe and you get a lovely cheese souffle. If you suddenly start putting in, big lumps of cheese or bits of bacon or something like that, you completely mix up the idea of a cheese souffle, and it doesn't work. I can tell you it doesn't work. And I think the problem is that geoengineering currently is more of an engineering project that doesn't really take into account the whole of the environmental complexity.
For scientists, very often their specialism is so precise and they are kind of observers and investigators of the dynamics of how a particular thing works. And then to see an engineer come in suggesting this kind of broad solution kind of flies in the face of the kind of very detailed work that they are doing to kind of uncover the kind of precise dynamics between different things. And it kind of feels instinctively wrong, perhaps.
True, but I think scientists have a role to play in geoengineering, in that they need not to just discount it completely. They need to help and work perhaps with the geoengineering projects and use the models and use the data that they have and the understanding of the complexity of the systems that they have to model the impacts of the approach. And it may be that they can see from their modelling, from their understanding of the impacts, that this is absolutely not the right thing to do. It could be a disastrous consequence, or they may say that it's actually it's not going to work. But I think the science must be done. If you're going to do geoengineering, you do have to understand the science behind it.
Yeah. So other scientists at BAS are engaging more collaboratively with some of these geoengineering proposals. That collaboration is possible because there's a funding challenge called Climate Cooling, which is run by ARIA, the Advanced Research and Innovation Agency. And so this programme they're running aims to, quote unquote, transparently explore under rigorous oversight whether any climate cooling approaches that have been proposed as potential options to delay or avert such tipping points could ever be feasible, scalable and safe.
Yes, BAS scientists are involved, and they're involved in a project called Ecological Impact Assessment of Earth Cooling Experiments in the Arctic, otherwise known as EcoICE. And what they're doing is providing an independent impact assessment for a project that's exploring ice thickening and widening in the Arctic. This science team at BAS is providing modelling to forecast what would happen if those technologies came out of the lab and were deployed into the environment. They aren't helping develop the technology, but they are pointing out where what is being proposed will have consequences based on what we know about that environment and ecosystem. So they're working alongside that project as external and independent assessors. And hopefully this will become a template for the sort of independent assessment we should be seeing for geoengineering projects before they're started. It's the kind of link between geoengineers and the scientists and their models that I think we need.
Yeah, I think there's been a lot of discussion around the kind of wider ethics of investing public money through bodies like ARIA in geoengineering. But I think it seems what you're saying is that we have to create that bridge between the kind of engineering industry and the science industry, and to have that kind of public oversight of these projects.
Absolutely. I think there's quite a lot of people with a lot of money who wish to see some engineering go ahead because they're worried about the rate of climate change. And I think the science must be in there to prevent further damage to the environment.
Yeah. So let's talk about the range of geoengineering techniques under discussion, because at the least controversial end of this field, we've got carbon dioxide removal and storage techniques. And these are the kind of things that were being talked about 20 years ago, and they're now part of UK government strategy for a low carbon economy. They're focused around major industry and providing that transitionary approach. They're a supported approach by the IPCC. What are the ingredients here that have helped that become an accepted part of strategy?
Well, we just know that we have to get rid of the carbon dioxide, don't we? I mean, we can stop carbon dioxide increasing at the moment, but we're still at a very high level and still in this unbalanced world that we talked about. So we need, if we want to go back to the world that we're in now or have been, we absolutely need to go back to those carbon dioxide levels and take carbon dioxide out of the atmosphere. And the way to do that is to bury it. So there are quite a lot of experiments going on around the world, and they have been for some years, to take carbon dioxide out, pump it back into voids in the rock. But the really key thing is you can't just put it as gas into the rock. You really need to turn it chemically through chemical reactions into rock itself. So I've been to Iceland, where there's a lot of basalt, lava that's come out of volcanoes quite recently, and it's full of holes because that's where the gas was in the magma that erupted. And as it solidifies, you can't get hard rock with holes in. And so in Iceland, they have big projects to inject carbon dioxide into the basalts, and the gas goes into the holes, and over time it reacts with the rock matrix, the geochemicals in the rock, and forms crystals of rock themselves. So it's actually trapped in these rocks.
That's amazing.
So it does work. And I know that for years, we've been pumping carbon dioxide and gases back into where we've extracted oil from. So there are holes in rocks under the ground. But the tricky thing is to keep them there. It's something we must do more about. The issue is scale. I mean, we need to put a huge amount of carbon dioxide back into the rock and seal it there. And I know there are people who've worked out, how long it's going to take and how much rock there is that we could potentially do this for. But it's something that we really, really have to move much faster on.
That's really interesting. And actually, something very satisfying about that, because it feels a bit kind of like the reverse process of extracting and burning fossil fuels, the kind of geological spirit of that part of works. That is very satisfying to hear about.
And the key thing is, if we can do that, if we can bury it as into the rock record, we're talking about millions of years. We're not talking about like the lifetime of a tree, which we're not talking about hundreds of years. We're talking about potentially millions of years, which is which is where we want to be.
Because, of course, actually there are other things which I think you could reasonably call geoengineering and have been called geoengineering that are, I think, now considered kind of fairly natural solutions. So planting trees and kind of that is also still fundamentally us tinkering with the climate.
It is, but, it's a natural way.
Absolutely.
There were a lot more forests on the planet.
We did the damage. So,
yes, so, hundreds of years, millions of years, the Earth was covered with trees. So, but trees have a lifetime, and there's only so many trees we can plant. But so we need to look at lots of different ways that we can pull out CO2 from the atmosphere.
Okay, so let's move over to the other end of that geoengineering spectrum, which is more focused on manipulating aspects of the environment that are being affected by emissions and warming, rather than the emissions themselves. And that is the revised definition of geoengineering that was offered in a new article that was published in Frontiers in Science this week. The article's called Safeguarding the Polar Regions from Dangerous Geoengineering, a Critical Assessment of Current Projects and Future Prospects. That paper does have a number of BAS scientists attached to it, and from the title you can already tell that the authors do strongly oppose these techniques.
Yes, in that paper they discuss several projects that really affect the polar region. So some want to actually remove water that flows between underneath the ice sheets to slow down the flow, because one of the issues is actually as glaciers speed up and they flow from land, where all this fresh water is trapped on land, but as the ice shelves melt and these big glaciers of water, tons of water potentially as a frozen ice block are coming down into the ocean, they melt, they're affecting global sea level. So the idea is to stop that flow, and also to build, the really interesting one is to build curtains around Antarctic glaciers. So it's ironic because the scientists have worked on a huge project recently, international collaboration, particularly with UK and US scientists, to look at the Thwaites Glacier. And one of the things that they've discovered is that warm water is being blown up, possibly by new winds, underneath the ice shelves at the edge of the continent, and is melting the ice from below. And so the idea from the engineers is to stop this warm water being blown up underneath the ice shelves, which will then free up the glaciers. And so the idea is to build a curtain around the front of the glacier to stop the warm water getting there. And I think that, the objections in the Frontier paper are quite right. I mean, it's physically almost, how on earth are you going to do that? You're working in Antarctica, you're working in incredibly deep waters and cold waters, but you couldn't just build a curtain around one glacier, because this must be happening all the way around Antarctica. You'd have to completely encase the Antarctic in a curtain all the way round to stop the water coming underneath. And currently, of course, we have a treaty that protects Antarctica, and there's no way anybody would get a permit to do that.
Yeah, completely. They've the kind of broad list of critiques that they've levelled at all of these projects are fair. So they've said these are unproven, untested methods. They could have unintended effects on the planet and ecosystems. They would entail massive costs to create and maintain indefinitely. There's logistics issues unlike any overcome before. There's a lack of geopolitical governance that in terms of what's currently in place and what would be needed, and that it diverts resource from those proven net zero plans. So they're fundamentally critiquing the idea that we should spend money and resource and time on this rather than cutting emissions. That's a fairly devastating critique, and there's a lot to unpack there, isn't there?
But of course, that's at present time, and who knows where we'll be in another couple of 100 years when radical ideas which we think are absolutely crazy now might be something that becomes more critical if we don't do something else. So that's what. So what we really must do is have much more focus on renewable energy, in new technologies that don't use hydrocarbons. Stop taking oil and gas out of the earth and start using renewable energy of all kinds, and invest in doing that a lot more.
Do you think there's a financial issue here between where that investment should go in terms of the action on on carbon reduction versus geoengineering, or do you think that actually we've got to look at the whole thing in the round?
Well, I think we just need to invest a lot more in using renewable energy and changing the source of the energy you have. That's absolutely critical. We've just got to get on and do that. But at the moment, a lot of the people that are funding some geoengineering are private funders who are really concerned about climate change, but they just want it to go a lot faster.
Yeah. And I guess you touched on this before, but there's obviously massive geopolitical governance issues, because often these are things that kind of cross national, international borders. They go into, if you're talking about the ocean, you go into international waters. Like, do you think that we currently have the political structures to take forward these kind of proposals, or do you think that is a big to-do list for the international community?
It's a very difficult geopolitical world to tackle climate change that way when we've got wars to deal with, when we've got people who are suffering so badly. In a perfect world, of course, climate change would be the big issue that everybody focuses on, and they would understand that we have to work across political borders to be able to solve what is a global problem.
So beyond providing scientific assessments, do you think that scientists have a kind of enhanced role to play in the public, in that kind of PR realm where we're seeing all of this chat about geoengineering? What do you think the role of scientists in that space is? Because I think understandably, lots of scientists really are anxious about entering that space.
In geoengineering, I think we need to do the science, and we need to explain to the public why we need to do the science. We need to understand what the results are of doing it. I think the scientists also need to engage, because I think they need to talk about not just about geoengineering, but about the climate problem as a whole. And how we use science to understand what's going on, improve the models, predict the future, understand what the world will be like in the future and what we will have to adapt to. If we want to adapt to a warmer world, then, what is it that we have to adapt to? If we want to return back to a world which is less warm and more like the one that we know now, what do we have to do? We have to decrease carbon dioxide. And how are we going to do that? How are we going to change the way we live? How are we going to change some of the technologies that we use? And how are we going to get carbon dioxide out of the system?
Thanks for listening to this episode of Beyond the Ice. I hope you enjoyed it and it has developed some of your thinking around geoengineering. If you enjoyed this episode or any of our previous episodes, it would be grand if you could go onto your podcast platform of choice and leave a rating or a review. It will really help other people find the podcast. Many of you may know that this podcast also comes out as a LinkedIn newsletter. And in that newsletter, we've got a quick read version of this conversation made up of some key quotes from Jane so that you can come back to them at your leisure. And obviously, a comment section is a great place for you to let us know your thoughts. So do mosey on there if there's perspectives you'd like to share. Thanks again for listening and see you next time.